Hey, welcome back to the channel. So today I want to share with you something that came to me in a dream, because I had a build that I was doing, and this was to automate the creation of long form videos, so long form script writing. And this was the build that I had for like 1 month, that I was trying to get it to work, but it never worked. And I can show you on Stack AI for you to understand kind of what this looks like. Basically, we have about 11 inputs, 4 different large language models, and a couple of databases, so it could generate, so it could do the task based on the data that we had. And this was the model that I was prompting and changing for a long time, but I never got it to work. Why? It was hallucinating a lot, because the heavy amount of calls it had to make, because it had 12 inputs in total, 4 different large language models, each one of them had one data loader, so it was in total 56, if I'm not mistaken, nodes. This is a node, so a node is a connection between, for example, data loader and a large language model. And pretty much I got large language model 1 and 2 to work, but then it got to large language model 3 and large language model 4, and it started bugging, meaning the output had nothing to do with the inputs that were provided. And why did we have to do it like this? Because the output, we can put it like this, the final output needed to be 8,000 words long. And if you have ever played with AI models, you'd know that Claude AI, so Anthropic's output limit is 2000 tokens, which is about 2000 words. It says it's 4000, but it only generates about 2 to 2500. So we had to divide it by 4 large language models if we wanted to get it to 8. This was the problem that we were having. Now this was like the build that came to me like literally in my dream. I am not bullshitting about this. And I built this wasn't the final build, but this structure helped me make it clear. And I want to run you through pretty much how we divided it, let's say. So keep in mind, here it was just one build, it wasn't working because of the hallucinations on large language model 3 and large language model 4. Pretty much what I started to do is like, okay, for all builds, what are the inputs that are needed for all builds? And I got clear on these ones. Then one thing we do for each video, so for not for each video, but for each large language model, is what are the arguments for each of the large language models to do at this part of the video. As you see, like these two, these are arguments. So this would be individual inputs for each large language model, meaning these ones, payoff 1 and 2, wouldn't need to be connected to large language model 2, but these inputs would always have to be connected with this, so it had context on what we are doing. So I started, okay, this needs to be universal across all builds. Then instead of doing multiple, one build with all large language models, I thought about doing individual builds. So it would look something like this. Instead of 12 inputs, only 5 inputs, and then 2 large language models per build. So you can see large language model 1 and 2. This is meant to act like a brain. I don't know, maybe let's put it in red, because red looks a bit like the color of a brain. With the prompts in this, firstly to summarize the information to make sure it picked up, because that was a problem we were having as well, meaning a lot of the detail we were providing here in the information and on the big idea wasn't being used in the large language models. And then the second large language model in this first build would be to script out the introduction and the first argument, let's say. And the information from this first large language model, so let me make it clearer for you. We have these inputs. Based on these inputs, firstly it would summarize the information according to my prompts to make sure it understood all information. Information would be received and it would be transported, so large language model 2 with these inputs as well and with this information, so double information if you think about it, so it's reinforced, would script out the intro alongside the payoff one. And in order for it to script out the intro like we want it to, we had 3 databases with examples on how to script it, so it would script correctly. So large language model 2 would have the databases, the information from the summary, the inputs, as well as these prompts. I'm not going to show you the prompts because this is, this is not the complete prompts. But yeah, it had to do this. One, it had to make sure it didn't end the article, because that was a problem we were having as well in here. I was having, where although it would be divided into 4 large language model, it sometimes, most of the times, it would end here. So like it would do a conclusion here and it would do a video introduction here. So this was something that took me a lot to like fix, because it was having a lot of hallucinations. Pretty much what I prompted is, what you are doing here is scripting one part of the article, understand the reading won't stop here, and the lesson only comes at the end of the video. In here we would get 2 outputs, so the summary and the first part of the script. And then we would move on to number 2, which would have the same inputs, these ones, and then a different argument. And it would do the same thing. So the first large language model would summarize it, it would transport it to large language model 2. I should have done it here. Let's fix it. Oops. Okay, now you're gonna see me in real time trying. Okay, let's go. And it would do the same thing. Data structures, prompts, and script out the second part of the script. Keep in mind, this is way, the goal with this is to make it way lighter on the large language model. So instead of here having all of these nodes, here it only has, okay, take this information, summarize it, send it to this one, and then this large language model, this brain, think about it like a brain. This brain picks up these data structures, these prompts, and then scripts out payoff 2. And then, as you see, we would do this all for each one of the payoffs. So 8,000 words, to us this meant 8 different arguments. So we built this structure for 8 different ones. And then pretty much what the user had to do, the end user, was he would enter all of the links. This would be all of the same, and then he just had to write payoff 1, so argument 1, argument 2, argument 3, argument 4, argument 5, argument 6, argument 7, argument 8, and then let each one of them run individually. This would take about 3 to 4 minutes instead of 2 hours for him to create the first structure. And we got this to work on Stack AI, but then, and I can show you because we moved all of our builds over to Make, so this is no longer the solution. I will find the solution so I can show you right now. Okay, so here it is. We ended up moving it to Make.com simply because of a reason. Found out that Stack AI was built on, our internal team found out that Stack AI was built on top of LangChain, and it didn't make the direct call to Make.com. What does this mean? Instead of, let me do it like this, and this is Claude output. Instead of when you made the call to Claude using Make, it's going direct to the output, which is the situation we have now on Make.com. It's going like this. So imagine something like this, that now let me make this differently, because I want to explain this concept to you, because this ruined a lot of my builds until I figured it out. LangChain stack. Instead of going direct and pretty much not messing with the information, it went through LangChain, which pretty much had a bunch of calls. From what I understood, I tested it, but I didn't understand the theory that much, but I understood what was happening, which was there was a step here in the middle using Stack AI, that was messing with our outputs. So we ended up building it on Make like this. Why? Because it makes direct calls to the API, doesn't rely on any third party. But this was how the first build looked like, so all of these builds individually. So you would have the first output being, this was a couple of months ago, so that's why I'm having a hard time forgetting, but now I can show this, so I'm showing it. This was the first build, which was this output generated the summary as I told you here, and then we would have the output here, so the explanation plus story for the first input. Exactly, and as you can see, this only had 4 inputs and 2 large language models instead of the one that I showed you at the beginning of the video, if you remember, which had 12 individual inputs, which was making the build very expensive. And we tested this with Llama, GPT-4 and Bard, and we ended up with Claude. I didn't put it here because it was the final one, 3.0. We ended up with Claude because this is something that you always want to test. If you are not getting a good output, it doesn't mean that your prompts are wrong. It can be the model, it can be the inputs, or it can be the data. And in this case, we tested each variable one against the other. So we tested the same prompts, the same database, and the same inputs with Claude, with Bard, with Llama, and with GPT-4. And over 50 tests. So, because this was Sonnet, and this was Opus, and we did 10 tests for each, over 50 tests, which is 10 plus 5 for those that are not following along. We clearly defined that Claude 3 Opus was the best on Stack AI, because on make.com Claude 3 Sonnet was the best. This is the importance of you testing each variable. And if you see this, what are the variables that go into one of these AI models? You have the inputs, so the information you are giving the brain in order to perform its task. You have databases, and you have the large language models, which include the prompts. So if you are not, and you have the model, so these models, if your output is not, and this is why building AI takes a lot of time, if your output is not being generated the way you want it to, it could be either one of these. It could be the inputs, that you need to give better inputs. It could be the large language models, so either the prompts, the instructions, or the model. It can be the data, so you need better data, or it can be a combination of all of them. It can be, for example, you not being clear on what this data is, because if I can show you here, okay, pretty much if you've seen any of my videos, here you'd have input 0 is X. So for example, input 0 is title of the video. But if you just put, like you see here, information for you to digest. But this wasn't working for me. I had to change this to, this is the information that we have in order for you to perform the task that you were instructed to. And that improved the output by like 1%. And you have to understand that with AI models, it's 1% at a time. 1% at a time. Once you've gotten to 85%. So you have 0, you have 85. Here it's the easiest to go, because at least for me, because I've done this so many times. 0 to 85 probably takes me 2 hours / 1 hour, depending on what the build is. But then from 85 to 100%, it can take me like 20 hours. Because this is where the value is. But yeah, I just wanted to show you this video. I don't know if it will be relevant to you, but in case you are building with AI and you have multiple different steps, this is a way that I found in order to make the output better, to make it cheaper, to make it faster, and to make it more reliable, because now it doesn't hallucinate. So I've now seen, if you can see on the bottom of my screen, it's 11:11, so I will end this video now. I appreciate the time that you took to watch this, because time is the most valuable asset that we have. If you'd like to have more time to work on the high ROI strategies and tasks that you need to, you can get in contact with us because we will help you do that. Have a nice day.